This lesson is a recap on Pythagoras Theorem. You might have even done this exercise already as part of your revision lesson for trigonometry. I did put the exercises up on the trigonometry topic already, so some of you might have completed them. But this is something we use a fair bit in this topic as well, in our surface area and volume topic. So we're going to have a good look at Pythagoras Theorem today. So if you've already done these exercises, congratulations, you don't need to do today's lesson. You might like to spend this time getting started on your trigonometry assignment, which was uploaded today. But this lesson will actually help with one of the questions in your assignment as well. So it might be a good idea even to just watch the video if you've already done the exercises, just so that you can refresh your memory. It's a good lesson to have under your belt. So Pythagoras Theorem. Okay, it's a theorem that only works for right angle triangles, okay? And we can see this is a right angle triangle here. We've got our right angle, and we've got our hypotenuse here, and then we've got our two shorter sides here. And basically all you need to remember for this theorem and to use this theorem is you need to remember this rule up here, and you need to know the sides of a right angle triangle. And we're all pretty familiar with the sides of a right angle triangle. Now we know what the hypotenuse is. We've worked with that a lot in our trigonometry topic. So this rule here, this equation, is always true for right angle triangles, okay? And the man who discovered that this was always true for right angle triangles was named Pythagoras. So that's why it's called Pythagoras Theorem. So c squared is always equal to a squared plus b squared for a right angle triangle. Now, what's a, what's b, and what's c, okay? They could be anything. So we need to make sure we know what C, A, and B are. Now C, that's the name that we give to the hypotenuse, okay? So in our right angle triangle here, you can see that the hypotenuse has been labelled C. And when we're using this theorem, we need to remember that C is always our hypotenuse. So if we're looking at a right angle triangle, we need to put the value for the hypotenuse in here. We don't want to put the hypotenuse here or here, okay? The hypotenuse always has to be in this position on the left-hand side, and the shorter sides have to be on the other side of the equation. So yeah, so C is the hypotenuse, and we have to remember that, and A and B, they're just the shorter sides, okay? And it doesn't matter which one's A or which one's B. In this triangle, we can see that this is A and this is B, but it could be the other way around. We could have said that this was B here and this was A. It doesn't actually change our rule at all. So it doesn't matter which way you put those two shorter sides in, as long as your hypotenuse is over here. So if we can remember that C is the hypotenuse, A and B are the two shorter sides, and we can remember this rule here, this C squared equals A squared plus B squared, then we're good to go, all right? And we can start working with our problems. It's a really good way to work out an unknown side in a right angle triangle. So we've been using trigonometry a lot and the trigonometric ratios to work out unknown sides in right angle triangles. And that uses two sides and an angle, those trig ratios, okay? They always use an angle, so it's like sine of an angle or tan of an angle or cos of an angle. And then they also use two sides in a ratio. So the sides are opposite over adjacent or opposite over hypotenuse. And every time you use one of those ratios, you use two sides and an angle. But what about if you have two sides and you want to find another side and you don't really care about angles? Well, that's when Pythagoras comes in handy. So find the length of the hypotenuse in the following right angle triangle. We need to find C. We want to find this length here, and it's already been labelled C for us, so that's nice and easy. Because we know we can use Pythagoras, and Pythagoras is this, C squared equals A squared plus B squared. We have to remember that one. So we can use this to work out C, okay? Because C is our only unknown. And we know that A and B, well, they're just the shorter two sides. So this is the length of one of the shorter sides. We could say that's 7. And this is going to be the length of the other shorter side. So we could say that that's 9.5. And we could have done it the other way around. It doesn't really matter. We just need to make sure that C is the hypotenuse. So let's plug our values into our equation. C squared, we don't know C, it's still unknown. We do know our two shorter sides, so let's put in 7 for A and 9.5 for B. So now we've got an equation here with only one unknown, so we can solve it. Everything on the right-hand side, we can just put into a calculator, and we can just evaluate that. 7 squared plus 9.5 squared. Kind of like we're just collecting like terms because these are all numbers. And it comes out as 139.25. So that's our right-hand side. And on our left-hand side, we've still got C squared. So we haven't quite found the length of the hypotenuse yet because this is the length squared. So we just want to isolate C by itself so we can get just the length here, which is just C. So then we need to take the square root of both sides as well. And because we're working with length, we can't really have a negative length, so we're not going to worry about the negative square root. So we're just going to find the square root of 139.25. We can do that on our calculator. And we end up with C is equal to 11.80 approximately. So C, our length of our hypotenuse is 11.80. So we had an unknown side in our right angle triangle, but because we had the other two sides, we could work out the length of this unknown side using Pythagoras Theorem. And all we had to remember was C squared equals A squared plus B squared, and we just had to make sure we knew that C was the hypotenuse. So example 2 here, again it's asking us to find an unknown side. It says find the value of the pronumeral, and you can see that the pronumeral is x here, and x represents the length of this shorter side here. So instead of finding the hypotenuse, this time it's asking us to find the shorter side. But it's all right because they've still given us the other two sides. And whenever they give us two sides in a right angle triangle and they ask us to find the missing side or the unknown side, we know we can use Pythagoras, because Pythagoras is an equation that ties all the sides of a right angle triangle together. So C is always our hypotenuse, and our hypotenuse is the side opposite the right angle, so that's this 13 here. A and B, they can be either one, okay? So A and B are the two shorter sides, and as long as we've sorted out our hypotenuse, it doesn't matter which one's A and which one's B of the leftover sides. So we can say that it's 12 squared plus x squared, or we could say it's x squared plus 12 squared. It doesn't really matter. Okay, so now we have an equation here to solve, and we've only got one unknown, so we can solve it, but because we're finding a shorter side, we just have to do a little bit more rearranging in this case. So we can evaluate 13 squared if we like. 13 squared is 169 here on the left-hand side. X squared, we can't really do anything with that yet, but we can also evaluate this 12 squared. So 12 squared is 144. And now we can just solve this equation by trying to isolate x using inverse operations. So if we want to get rid of this 144, we just subtract 144 from both sides. So 169 minus 144 here is 25. So 25 equals x squared. We're getting closer to finding x, which is what we needed to do. We needed to find the missing side here. We just need to take the square root of both sides to get rid of this power of 2. So what's the square root of 25? I just had the answer. The square root of 25 is 5. And the square root of x squared is just x. That's how we got rid of the power. So now we have 5 equals x. For convention's sake, we like to write it the other way around. We always have the pronumeral on the left, but it doesn't really matter. We know that the value of x is 5. So we found the value of the pronumeral. So x here is 5. And we can use Pythagoras Theorem to find any of the sides. We can use it to find the hypotenuse or one of the two shorter sides, as long as they give us the other two sides in the question.